Hello and welcome to my presentation about supply chain management regarding my portfolio by Jasper Ansems. First up is the content. We're going to discuss in total 15 things, and they're shown here. First up is materials management. So supply chain management is the whole process of business. It starts with raw materials, goes through the supplier to manufacturing, warehousing, then comes wholesale, retailer, and at the end the customer. So the operation environment of supply chain management is in the government, the economy, and global competition, and also customers' demands. Next up is manufacturing strategy. So how are we going to deal with the requirements of the customer? And there are a couple of things, couple strategies. First up is make to stock. Make to stocks is manufacturer produces the goods in anticipation of the customer demand. And there's a little customer involvement, so the delivery lead time is only in the shipment. You also have assemble to order, and then the delivery lead time is also within the inventory. So manufacturer assembles the good based on the customer order. Then you have a make to order. Manufacturer assembles the goods based on a customer order. So the assemble time is also involved in the delivery lead time. And you also have engineered to order, and the manufacturer does not start until the order is received. So it starts at design and all the way to the shipment is the delivery lead time. You also have the client order, the decline point, and that tells us how far the specific order of a customer influences the production process. So material management is actually a balancing act. You need to find a good balance between the customer server and the cost of providing the service. So the priority for the customer server is the demand for the products, and the capacity for the cost of providing the service is the ability to produce products. Next up is production planning system. This is a key to match priority and capacity. So the priority is what is needed, when and how much, and the capacity is the capability to produce what is needed and when. So on the right you see a pyramid, and it starts up with the strategic, tactical, and operational, and in order of time span it goes from long to short. So strategic is long and operational is short, and in order of details it's general and strategic, and very detailed and operational. So a planning hierarchy, it starts with an annual planning, so strategic business plan, and that comes to a monthly production plan, and that comes to a weekly or daily master production schedule. And the first three things are all involved in the master plan. And next up is the material requirements plan and capacity requirements plan, and those four things together are all planning, and at the end is the production activity control and purchasing, and that's a part of the implementation, which is an ongoing process as well. So capacity management. At each level of the planning and control system, reconciliation with resources must be made. So must obtain the right resources or change the plan. Inadequate resources is missed production schedules. Resources significantly exceed planned production, idle resources, and extra cost. So what are the basic production plan strategies? You have the chase strategy, the level strategy, and the hybrid strategy, and I'll show them on the next sheet. So the chase strategy is a demand matching strategy. So what's in the forecast is actually planned for the production. The level strategy is you want to get like a smooth planned production, so more like the average in production schedule. And there's also a hybrid schedule, and that's a combination of the chase and the level strategy. So how do we calculate the holding cost per period? The holding cost is the average stock times the cost per unit per period, as you can see here on the graph. So the next chapter is master scheduling, which starts with the aggregate production plan, then it comes to the master production plan, material requirement plan, then a detailed capacity plan, and then you ask yourself the question, is this realistic? And if so, you execute the capacity plan and you execute the material plans. So the information needed to develop an MPS is a production plan data, the forecast, actual customer orders, inventory level, and capacity constraints. So here we see an MPS matrix filled in. You can see the forecast, the orders, and the project available and available to promise. Also, and this is already filled in, so the points from the previous slide are filled in this sheet. So next up is the material requirements planning, and you have two kinds of demand. The first one is an independent demand, so not related to demand for other assemblies or products, instead from outside sources, and this is generally forecasted demand. And the dependent demand generally related to production of an end product as defined on the MPS and can be calculated instead of forecasted. So we can see here the difference on the right in the table between those two kind of demands. So what's the input and the output for an MRP system? So we see here the material requirements planning system in the middle on what will go in. So bill of material and item master on the left, a schedule on the top, and inventory status and the purchasing data on the right, and then what comes out is a planned order report and other reports. So the build of material into the multiple level bill. You can see here on the left there is a visual of what we need to assemble a table, and that visual is shown in a table on the right where you can see how much do we need for each part. This is a BOM in short. So there are some key items in the material requirements plan. The first key item is the lead time, and it's the span of time for a process. You have exploding, so the process of multiplying requirements by users to get the BOM requirements, offsetting placing requirements in the proper period based on the lead time, planned orders ordered planned during the explosion but not yet released for processing, low level code, the lowest level on which a part resides on the bill of material, scheduled receipts, open orders released for processing, gross requirements, the total of a component needed to meet requirements not taking any existing inventory into account, and then you have the net requirements, the actual amount of the component needed. So all those key items will fill in on the next sheet. Here you can see the next sheet, in which is a filled in material requirements plan. We can see the weeks on the right on the top, the low level code on the left, the part numbers, and then we can see what we need of every part for every week in project available and planned orders. So how does a closed loop MRP system look like? You have a planning part and an execution part. So the planning part, as we said earlier, is start with the production plan and is divided in a priority and capacity planning, which are related to each other. And then when it's realistic and the material requirements are very detailed and the capacity requirements are detailed, you go to the execution. And in the execution you have the priority control and the capacity control. And at the end you come to the end when you execute the final plan. Chapter 5 is capacity management. Capacity planning levels. You have the resource planning, so long range resource requirements linked to the production plan. You have the ROT cut capacity planning, and this is used to check feasibility of the MPS, the master production schedule. You have also capacity requirements planning, and this is a detailed work center capacity plans linked to the MRP, and the input is an open order files, planned orders released for the MRP, a work center file, and a routing file. So how does an explosion in an MRP1 system look like? You have here two different parts, part B and part C, but both parts need part S, so part B and part C come together in the gross requirements for part F. So what's the capacity available? It's impacted by the project specification, the project mix, the method of use and the pace of work. So rated capacity is available time times utilization times efficiency is available time times the number of hours a work center can be used. You have also scheduled orders. You have a back scheduling, the typical approach, a forward scheduling, and the back scheduling is start with the due date and use lead time to find the proper start date for each operation. And the forward scheduling is launch the order into the first work center, then use the lead time to find when the order will be completed at each work center. You can also adjust the capacity, use overtime or undertime, adjust the number of workers, shift workers from other workstations, use alternative work centers to shift load, and subcontract work or, of course, outsourcing. The next chapter is purchasing. Purchasing starts with the purchase requisition, and then you go to selecting the suppliers, determining the right price, issue purchase order, follow up delivery dates, receive and accept goods, approving suppliers' invoice, and after sales service of suppliers. And how do we select a supplier? You can use a weight point plan, as you can see on the right. So you have like different factors and different suppliers, and you all give them a score, and then in the total column, total row on the bottom, you can see which has the highest score, so which supplier you need to select. Next up is forecasting, underlying basis of all business decision actually. So you have forecasting in production, in inventory, and personnel, and in the facilities. You have different types of forecasting. You have the long range forecasting, strategic planning. You have the medium range forecasting, and tactical planning, and of course operational short range forecast. So you have different forecasting realities and approaches. A couple of realities as a forecast are seldom perfect. Most forecast methods assume that there is some underlying stability in the system. And forecasts are more accurate for families or groups or projects for a time period closer to the present. And every forecast should include an estimate of error. And you have also approaches. You have a qualitative method and a quantitative method. So quantitative forecasting models, there are a couple of. You have the time series, which conclude moving average, exponential smoothing, and trend projection. And you have also linear regression in the associative models. So next up is the inventory. You have the buy side, the production side, and the sell side, and on each side there are inventory is involved. As you can see, there are a couple of points per side which are important. So in the inventory you have the possibility to make an ABC analysis, and this divides on hand inventory in 3 classes to determine the relative importance of inventory. So the degree of control based on the ABC value is that the A items is about 20% of the items and 80% of value. B items are about 30% of the items but only 50% of the value, and C items are about 50% of all items but only 5% of value. So the basis is usually annual euro volume. So euro volume is annual demand times the unit cost. And what percentage are used to classify items into ABC? You can see on the right graph how that is determined. So next up is the inventory management. You have three kinds of inventory management. You have the lot for lot, and this order exactly what is needed. You have the fixed order quantity, order the same amount each time, and you have the periods of supply. so order enough to cover a demand over a certain period of time. So there is a technical stock curve. This is a graphical representation of the stock level per time unit, as you can see in the 3D graph. So for instance, there will be more gifts bought during September and October and November for instance Christmas. So there's also a traditional stock control, and this determines when to reorder your projects. So the reorder is triggered on the blue dotted line, and the stock average is always Q divided by 2, and there's always a lead time, so you need to know the lead time to know when to reorder. So chapter 10 is the independent ordering systems. Why do we need safety stock? To protect us against uncertainty in supply or demand. And safety stocks for uncertainty in quantity, not in quality. And there's also safety lead time, uncertainty in the timing, delivery or late delivery, and they both increase stock. So warehouse has a couple of activities. They receive goods, and that's acceptance of goods from outside transportation or an attached factory. They identify the goods with appropriate stock keeping unit numbers SKU. They dispatch goods to store it and record the location. They hold the goods. Storage is meant to protect the goods. They marshal the shipment. All goods for an order are brought together. Then they dispatch the shipment. The order is prepared for shipment and loaded on the right vehicle. And they pick goods. Goods are picked from storage. So what is physical distribution? Physical distribution is from the manufacturer to the customer. So you have the supplier to the manufacturer, but that's not physical distribution. It's from the manufacturer to the customer. Here you can see two different channels. You have the distribution channel, which is concerned with delivery of goods, and you have the transaction channel, and the transaction channel is more focused on negotiating, selling, contract, and concerned with the transfer of ownership. So there are two different channels which continue on the same amount of time, and at the end the project comes to the consumer. So logistics, you have reserve logistics, a complete supply chain dedicated to the reverse flow of products and materials for the purpose of returns, repair, remanufacture and or recycling. You also have green logistics, which is a return and disposal of packaging materials, return and disposal of environmentally sensitive materials, or the use of reusable packaging. Chapter 13 is the products and process. So a product has a product life cycle as shown on the right, which starts with the introduction, then it continues with a growth, then you reach the maturity phase, and at the end you have the decline phase. So there are a couple project development principles. The first one is simplification, and that is to cut waste by eliminating unnecessary variety, sizes and types. You have standardization, develop a well-defined specification for material configurations, and you have specialization, and that's focus on effort and design. So chapter 14 is the lean production. You can see here a lean manufacturing, which is all evolved around the quality, and the quality is divided in delivery times and cost. So we're going to tell something about a couple things from the lean manufacturers. First up is the value stream mapping. We're going to discuss Kaizen. The takt time is the working hours divided by an hour. So average unit divided by an order, so average unit production time, and also the 5S approach. So what is value stream mapping? It starts with communicating value need to the stakeholders. Then you map the current state, identify future state needs, and create transformation plan. And that comes to socializing and standardizing, and that's a repetitive circle, so every milestone you restart. So next up is Kaizen, and Kaizen is a continuous improvement in all organization levels and processes, and it starts with defining, measuring, analyze, improve, and control. And this is a different way of plan the PDCI circle, so plan, do, check, act. There's also a 5S approach, and it's a continuous circle, and the 5 S's are the first letter of each subject. So set in order, keep needed items in the correct place to allow for easy, immediate retrieval. Shine, keep the workplace neat and clean. Standardize, the method by which sort, set in order, and shine are most habitual. Sustain, maintain established procedures, and at the end sort. Clearly distinguish needed items from unneeded and estimate the latter. Finally, you have the materials management, and you have the total quality management. TQM is based on the participation of all members of an organization in improving processes, goods, services, and the culture in which they work. So TQM is focused on 5 things. Focus on the consumer, continuous improvement, quality improvement, accurate evaluation, and involve all employees. So you have different costs in material management. You have the internal costs, which is scrap, external costs, for instance, and warranty, prevention costs and training, for instance, the employees, and appraisal costs, and that's inspections. Finally, you have the statistical process control, or SPC for short. SPC attempts to find assignable causes and helps select processes that are capable of producing quality projects, and they monitor processes to be sure it remains capable of producing quality projects. And Six Sigma is an extension of the SPC to business processes, and it's a continuous improvement. So you can see here on the right in the table what the Six Sigma actually meant. So for instance, at the Six Sigma level 6, there's an accuracy of 99.9997%, and the DPMO is only 3.4. This is the end of my presentation.